Hi everyone, I am Dr. Bhanu Murthy, Assistant Professor, Mechanical Engineering Department, VIGNANA JYOTHI. My area of interest is automation and robotics. Today we are going to deal Introduction to Robotics module. So let's get into the topic. So introduction to robotics, and these are the agenda points today which we are going to discuss. So let's get into the topic, history of robotics. So history of robotics from 1920 to 1950. Let's see. Czech writer Karel Čapek in his drama introduced the word called as robot to the world in 1921. So it is derived from Czechoslovakia word robota, meaning forced laborer. Isaac Asimov, the well-known Russian science fiction writer, coined the word robotics in this story Run Around, published in the year 1942. So before 1920, the concept of robot was 3000 years back itself. So the ancient times, including Indian legends describing mechanical elephants used for gardening purpose. So these early ideas represent primitive form of automation, reflecting humanity long-standing interest in creating machines that can mimic like living things. So the first industrial robot Unimate was developed by George Devol and Joseph. In the year 1961, it is been installed in General Motors plant in New Jersey, USA. So this is a picture which you can see here. So photo of a Unimate robot, and the purpose of the robot is handling hot die cast metal parts at very high temperatures, picking components for molds at repetitive motions, and placing them in trays at dangerous working conditions. So that is how it is been. And after that, what is robot and what is automation is the difference between many students. So is automation and robotics are both same or different? So let's see what exactly they are. So automation involves the use of mechanical, electrical, electronic and computer based systems to perform tasks without human intervention. However, not all automated systems are robots. A robot is an intelligent, programmable machine capable of interacting with and modifying its environment. Unlike fixed automation systems such as CNC machines, robot possess sensing ability and reprogrammability. All robots are automated systems, but all automated systems are not robots. So that is the difference which a robot and automation is all about. We have to notice it. The progressive advancement in robots is classified into generations based on their capabilities. Into 4 generations. Let's see what are the 4 generations. The first generation, without sensing the ability, repetitive tasks are being performed, which are very simple tasks. Repetitively, it is been performing without sensibility, without any sensors and feedbacks. The limitations of the first generation was being overcome by the second generation robots, including sensors and feedback systems. And third generation robots incorporated with artificial intelligence and learning capabilities. And the fourth generation, it is being expected to be fully autonomous and human-like characteristics, which can able to judge the things and perform the task instantaneously. So that's how the difference is. This evaluation reflects the continuous improvement in robotics technology towards intelligent and adaptive systems. So this is what is and what not a robot. This is the difference between an automation and the robotics. The point I wanted to highlight here is all robots are automated systems, but all automated systems are not robots. So definitions of robot. When you're thinking about the robotics definition, of course, every organization has its own definition and their standards. Let's see what are the definitions with respect to the organizations. So first one, RIA, Robot Institute of America earlier, and it is been now RIA, Robotics Industrial Automation. Definition: a robot is a reprogrammable multifunctional manipulator designed to move materials, parts, tools, or specialized devices through variable programmed motions for the performance in a variety of tasks. Let us go in depth after seeing all the different organization definitions. ISO standard. A robot is an automatically controlled, reprogrammable, multi-purpose manipulator programmable in 3 or more axes. So, Japan Industrial Robot Association. A robot is a machine that can perform a variety of tasks automatically under programmed control. British Robot Association. A robot is a reprogrammable multifunctional manipulator. And the last one is AI, Intelligent System Perspective for this slide. So, a robot is an intelligent system that can sense its environment, process information, and act upon it to achieve specific tasks. If at all we see in depth of it, all the organization are focusing on three major aspects. One is reprogrammable multifunctional manipulator. These are the three words which are being used in all the organizational definitions, as the robot is capable of performing any task with respect to the program. So that is important. As the program is being changed, the task performance is also will be reflected according to the program. That's what reprogrammable multifunctional manipulator. Okay, hope it is clear. And now moving on to the next, anatomy of a robotics. Robotics anatomy, if at all you compare with a human being, the skeleton of a human body, okay, similar to a robot anatomy. Robot anatomy consists of different links, joints, sensors, actuators, end effectors. Of course, it need to be controlled with an controller, and it is all these things are being mounted on so-called as base. So these are the different components of a robot which has its own importance in functioning for a specific application. Okay. So moving on to the next, laws, 3 laws of robotics, which is been derived by Isaac Asimov to ensure ethical behavior of robotics. Why the ethical behavior of robotics is to be mentioned is, most of the cases all the human beings are being frightened of robots. So if robots are they taking away their jobs? So this is a big question mark to everyone. So in order to make sure that they are just meant for helping human beings, not carrying away with human beings, okay, without the significance of human beings, robots are not existing, and that is being ensured with these 3 laws. Let's see what are the 3 laws. First law, robot must not harm a human or allow human through inaction. First one. Second one is, so robot must obey human commands unless they conflict the first one. Third one, the third law states that a robot must protect its own existence until unless without conflicting the first 2 laws. Okay, so these are 3 laws which are being protecting the human being from the robotics and robots. So thumb rules for design of a robot usage. The purpose of the robots, as I told you, it is to assist human beings, not carrying away with the human beings, making it to side channel. So let's see what are the robot usages. There are 4 Ds of robotics. 4 Ds. A task suitable for robots if it is dirty. So where a human being cannot perform tasks which are very dirty, okay, which are dull, in the sense boring, repetitive, clerical tasks, which are dangerous, risky to human being, And the last is difficult, where human being cannot perform with high accuracy and precision out of his strength. So these are the four D's. Because of these four D's, the robot is being evolved. Robot is being using in the current generation and in future generation also. It will not take away the jobs of human beings. It is for making human beings comfortable and making the process easier. That's it. No need to get panic where robots will take away the jobs of human beings and make the human beings jobless. No, not at all. Okay, so let's see. So joints and joint notation schemes. When you're talking about anatomy of a robot, we have discussed about links and joints. So here the joint comes. So joint notation represents a type of joint in robot using symbols such as revolute joint, and a prismatic joint. Revolute joint are meant for rotational motion and prismatic joint for linear movement. Robots are being classified based upon these combinations: PPP, RPP, RRP, and RRR. So we'll see in further session excuse me. So we are going to see what exactly the combinations are. So these are the revolute joint, how it is being represented: revolute joint, prismatic, rotary joint, and twists. So these are the different types of joint used in the robots. So let's see what exactly and how the combinations are meant. So robot coordinate systems. Cartesian. First one is Cartesian, where we have seen just now PPP. Yeah, this is how it is. All the three axes. So a Cartesian robot is a manipulator with three prismatic providing linear motions: x-axis, y-axis, and z-axis, where you can see the linear movements. With this linear movement, when it sweeps 360 degrees, the cuboidal shape will be formed. It is simple in construction, high accurate, and easy to control. Two types of Cartesian configurations are cantilever and gantry. So this is how, when it is swept in 360 degrees with their maximum to minimum sizes or limits called as. So this is how the work envelope of Cartesian coordinate systems will look like: cuboidal or a rectangular shape. Okay, that is the reason it is called as rectangular coordinate systems, Cartesian coordinate systems, or rectangular robot. So this is a image where you can see the movements of x, y, z, how they are going to move. And so best example is 3D printers or CNC machines. Moving on to the next one, cylindrical robot, RPP. The combination RPP, revolute, prismatic, and prismatic. So this is the image where you can see the first column, vertical column, will be rotating, and D2 and D3 are the prismatic joints where they linearly, along with the rotation, it will be moving up and down, and D will be sweeping 360 degrees, where the hollow cylindrical region will be its workspace or envelope, we call it as. So the application of it is welding pipes working inside cylindrical surfaces, reaching into holes or machines. Cylindrical, first one is circle. Height, it will be moving up and down, and radiusly it will be sweeping. This is how it will work, and this is the shape of the work envelope. We call it as spherical or polar robot. So this is how the construction of polar robot looks like. We have RRP. R is revolute, and second one are revolute, and P is prismatic, where we can see the first one rotates and second also will be rotating. The polar robot is a manipulator with two rotary joints and one prismatic joint. It consists of a rotating base, shoulder as a telescopic arm. The workspace of a polar robot is a spherical in shape. It allows the robot to reach a wide area, including regions below the base. It can go beyond the base So it has more reachability in compared to the other robots. However, it has lower stiffness and reduced accuracy at higher extensions. The applications of it is welding, spray painting, die casting, working on the curved surfaces. Advantages: large reach, flexible movement, good for curved surfaces. And this is the shape, work envelope. We can see how it can be a polar. That is the reason it has been spherical in nature. So that is the reason we call it as spherical robot or polar robot. Articulated or revolute robot. So here articulate robot is a type of robotic manipulator consisting of 3 or more revolute joints. 3 revolutes, RRR. We can see RRR. Revolute joints, commonly represented as anthropomorphic robot manipulator is also. So what does it mean? It means it's human-like characteristics where from the shoulder to the wrist. So what are the human beings we have? The same configuration is being introduced into the robot called as articulated robot. So this is how base, shoulder, elbow, end effector is being designed. And so we can see the envelope, work envelope will be like this. So advantage is very flexible, high range of motion, easy to fabricate and maintain. Scara, selective compliance assembly robot arm. So the combination here is we have this is R, this is R, and this is P. Earlier we have seen the same combination RRP as spherical or polar configuration. But whereas in this the same configuration, but the combination of the links and joint are being varied in order to have different coordinate systems and different orientation so that it can work in a different environment, so which is being extensively used in electronic industries for assembly purpose. So here we can see consists of 2 rotary joints in horizontal plane and 1 is prismatic vertical. The unique feature Scara is selective compliance, meaning it is flexible in horizontal direction and rigid in vertical direction. So it provides high speed, precision and stability, making it suitable for assembly operations. So the workspace in cylindrical is shape. Scara robot are widely used in electronic assembly, pick and place operations, packing industries. Advantages: high speed operation, high precision, good stiffness in vertical direction, suitable for assembly tasks. Applications: electronic assembly, pick and place operation, packing, small part handling. Disadvantages, of course, limited reach based upon the limits, length and all, not suitable for heavy loads, limited flexibility compared to articulated robots. Comparison of the robots. So this is very beautiful thing which we can see. So Cartesian, cylindrical, spherical, articulated, all the 4 are being compared with respect to their coordinate configurations, where the first one, just recollect them. So PPP and RPP, RRP, RRR. So these are the 4 combinations. Of course, the same RRP we have the other one called as Scara, right? Hope you have remembered that. And advantages and disadvantages, of course, we have discussed already. I'm not going into this. You can see robot classification based on control systems. This is again important. Limited sequence, point to point, continuous path and intelligent robot. So what is limited sequence? Limited sequence, of course, point to point. So it has, say for example, a beautiful example which I wanted to give you is in as automobile industry assembly line. Okay, assembly process. So assembly line, we have different workstations where each and every workstations are dedicated with one specific type of application. Say spot welding is one of the example, and in the same way windshield fixing and all, gluing, all these things will be considered as limited sequence. It cannot go. So in the whole assembly line it will be processed at once one application, and it will be moved to the next workstation, next application, third one in the same way. So point to point application is something. Spot welding, you can take an example. Best example is spot welding. Spot welding, if at all spot welding need to be done. So spot welding is not a continuous one again. It can be performed as and when it is required and wherever it is required. So that is what the point to point. And third one, continuous path. Continuous path is, say for example, spray painting is to be considered. Spray painting can be considered here for continuous path, where the painting is continuously throughout the surface of the plate, for example. Okay, so it need to be monitored each and every second of its movement. So its trajectory, we can call it as an intelligent robot. Of course, it uses the sensors, AI, to adapt to the environment, where it can collect the information. It works according to the requirement. So let's see the examples here. The first one, where you can see the welding kind of thing, attachments are being done, and here it is spot welding, the second one. And the third one, you can see the arc welding is being done, where arc welding is also continuous. Spot welding is point to point, and the third one, continuous path. Arc welding is required again. Spray painting, it can be spray painting or arc welding, anything can be possible. Of course, you can see it is surveillance. It does appropriately, instantly. So this is again a small comparison, how it works, where it works, what to be controlled, how much it can be controlled, what is the key ideas of it, and all are mentioned clearly. So need for robotics. So the purpose of robotics is, as I told you, 4Ds, right? So all the 4Ds will be incorporated in these things. Precision and safety. Yes, safety, dangerous, as I told you. And robots enhances productivity through continuous operation. Okay, continuous operation. Clerical task, dull, we have seen, we can compare it. Improve accuracy, again dull. Operate in hazardous, dangerous environment. They reduce human errors, again mistakes. Okay, offers flexibility through reprogrammability. Yes, it can, whereas human cannot. Human needs time to learn new things and adapt to the environment, right? But whereas here we can reprogram it, and it works according to the situation required. Ensures consistent product quality, and integration with advanced technologies such as AI and IoT further can be added. Despite high initial costs, robots provide long-term economic benefits and play a crucial role in achieving global competitiveness and smart manufacturing. So these are the necessities and needs of robot to be in this generation. Applications, of course, industry, industrial application, medicine, agricultural, transport, home, defense, space, and many more. So some of the pictures where just how it is being assisted and how they are being used currently today. So these are the areas where the applications of robots are extensively being used, and further generation it will be into a peak level where humans are meant to supervise the robots, and robots will be performing tasks so that everything goes smooth, and productivity, living standards, everything will be improved with these kind of things. And these are the MCQs where you can go through these things and you can try to answer the questions and all. Thank you so much. We'll meet in the next session.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.